Hello everyone, these are the notes for Module 8B, which deals with graphing lines, and we'll focus on 3 ways to graph lines, starting with using a table. So example 1, you're asked to use this equation and use any of the 2 points you determine from the table to graph the line. So we completed tables in Module 8B. We'll use those same methods. You want to look at your table as being divided into 2 columns. The column on your left is your x coordinate. The column on your right is your y coordinate. And we'll take each row one by one. So this is row 1, row 2, and then row 3. Now row 1, we have the y coordinate is 0. So using our equation, we're going to substitute 0 for y. Look at our equation, it's x minus y equals 3. Where y is, you would substitute 0. So it'll become x minus 0 equals 3. So x minus nothing, therefore x is equal to 3. Now when we replace that x coordinate with 3, that ordered pair becomes 3, 0. We can go ahead and plot that point. So 1, 2, 3, 0 will be right here on the x-axis. I'll just label this ordered pair. Now let's look at our second row. Our x coordinate is 1. So using our equation, we're going to substitute 0 for 1. Or excuse me, substitute x with 1. So x minus y equals 3. And we're replacing x with 1. So we have 1 minus y equals 3. We want to subtract 1 from both sides of the equation. The 1's will cancel on the left, leaving negative y equals 2. Now you want to see this negative y as negative 1y. The reason why that's important, let me recopy it here, negative 1y equals 2, is because we need to get rid of the y, the negative symbol that's in front of the y. And in order to do that, we're going to divide both sides by negative 1. That'll cancel out the negative symbol, giving us y. And it equals 2 divided by negative 1, which is just negative 2. Our y coordinate for the second row is negative 2. And the ordered pair is 1, comma, negative 2. So we're going to go to 1 on the x-axis, down to negative 2 on the y-axis, and plot the point. So 1, comma, negative 2. Now this is all you needed in order to graph this line. You needed 2 points. So we're going to graph the line by connecting those 2 points with a line, and make sure you have arrows at the end of both of your lines to indicate the line continues to go on forever in both directions. Now your table is still incomplete. So row 3, we need to find this last missing piece. For the last row, your y coordinate is equal to negative 1. So we'll use the equation again, x minus y equals 3. And we'll substitute negative 1 for y. So x minus, and in parentheses we'll add negative 1 for y equals 3. Now by me having the 2 negatives side by side, that becomes x plus 1 equals 3. We'll solve this equation by subtracting 1 from both sides. 1's will cancel on the left, leaving x equals 3 minus 1, or 2. That last little space in your table, you put 2 for your x coordinate. Now let's move on to problem number 3. Now another method we could use to graph equations are using the x and y intercepts. So I'd like to find the x and y intercepts using 2 columns, your x-intercept column and another for your y-intercept column. Now there's some basic facts about the x and y intercepts. Remember, an x-intercept is the point where you cross the x-axis. So anytime you cross the x-axis at that point, your y-coordinate will always be 0. So to find the x-intercept of any equation, you would substitute 0 for y. Now the same thing goes for your y-intercept. If you're on the y-axis and you draw a line through the y-axis at this point where you cross the y-axis, you will be at 0 on the x-axis. So your x-coordinate will always be 0 at your y-intercept. So to find these 2 points, we will substitute 0 for y to get the x-intercept. We'll substitute 0 for x in order to get the x-intercept. So we'll use our equation x minus y equals 5 both times. And then we'll substitute our zeros in the correct space. So looking at the x-intercept, where the y-coordinate is, we'll replace the y with 0. So it becomes x minus 0 equals 5. X minus nothing, so x equals 5. That ordered pair, your x-coordinate is now 5, but remember your y-coordinate is 0. So that ordered pair will be 5, 0 right here. Let's just label as 5, 0. Get rid of these extra lines. So that 5, 0 is our first point. Now we'll substitute 0 for the x-coordinate in order to get the y-intercept. So 0 minus y equals 5. Remember, we want to see this minus y as negative 1y. That'll remind us to divide both sides of the equation by negative 1 in order to get rid of that negative symbol. So y equals 5 divided by negative 1, and that'll be negative 5. Our ordered pair, our x-coordinate is 0, and our y-coordinate we just found was negative 5. So 0, negative 5, 0, negative 5 on the y-axis. We'll connect these 2 points in order to graph the line. We'll connect the 2 points, and we want to draw arrows at the end of our lines. Now let's look at number 10. We're graphing this equation. Now the third method that we'll look at for graphing lines is using the slope-intercept form of an equation. So whenever we have an equation where y is by itself, it's written in slope-intercept form, and we can use the slope, remember that's the letter m and it's the number in front of x, and the y-intercept to graph the line. Remember b, the number at the end, is our y-intercept. So in this case, our b or our y-intercept is 4, and our slope is negative 1/3. So we'll just write that bit of information down here. Our slope is negative 1/3. Our y-intercept is 4. Remember, m is your slope and b is your y-intercept. What you want to do is first plot your y-intercept. We want to plot this point first. Since our y-intercept is 4, we're going to go to 4 on our y-axis. Here's our y-axis moving up and down. We're going to go to 4 and plot that point. That's our y-intercept. And then we'll use the slope in order to find a second point. You use your slope in the form that rise over run form. Remember your rise over run that we learned about slope. What that tells us is how far up or down on the y-axis. That's your rise. Am I moving up or down? It depends on my sign. Because it's a -1, that means we're going to go down one space. Now, regarding our run is the shift on the x-axis, how far to the left or to the right we go. If it's a positive number, we're going to move to the right. If it's a negative number, just like on the number line, we're going to move to the left. But it's a +3, so that means we're going to move to the right 3 spaces. Starting at our y-intercept, the first point we plotted, we're going to move down 1, right 3, and plot the point. So down 1 space, right 1, 2, 3, plot the point. And there we have our 2 ordered pairs. We can graph the line by connecting those 2 points. All right, let's move on. To the next highlighted problem, which is number 15. We're graphing this linear equation. We have x equals 6. So all that means is we're going to cut through 6 at the x-axis. So we're going to go to the x-axis right here. That point would be x equals 6. So our point is x equals 6. So we're going to go to x-axis and plot that point right at 6. Now remember, when you're doing your graphs, you're going to need at least 2 points. The graph of this line moves up and down through the x-axis. It's a vertical line that cuts through the x-axis at 6. But in order to graph a line, you need at least 2 points. So after you plot the point x equals 6, you're going to have to either move up or down a couple of spaces and plot a second point and just connect those 2 points to make your vertical line. But you have a vertical line through the x-axis at 6, and that's your graph. Now, if you have an equation similar to example 17, we have x minus 4 equals 0. You want to, in this case, solve this equation for x. So you can add 4 to both sides. And we'll get x equals 4. Therefore, this graph is going to go through the x-axis at 4. So we're going to go over here to our coordinate plane and plot the point 4 on the x-axis. And then we're going to either move up or down, connect the 2 points, making a vertical line through the x-axis at 4. So this will be our graph of x equals 4. All right, let's move on to number 19. We're graphing this equation. Now look at the form of our equation. It's in slope-intercept form, that y equals mx plus b form. So we can use our slope and our y-intercept to graph this line. Our slope will be the number that's in front of x, so -3/2, which means when we get to this point, because I have a negative number in my numerator, my rise section, it's negative, I'm going to move down 3 spaces. In the denominator, we have +2, which means we'll move to the right 2 spaces. And our y-intercept is 3. We'll start here. We want to plot this point on the y-axis. We'll go to 3 and plot the point. Oh, we're on the x-axis, so let's delete that. And let's move to our y-axis up to 3. And we're going to use our slope to find a new point. We're going to move down 3 to the right 1. So from y equals 3, we'll move down 3 spaces, 1, 2, 3, and to the right, 1, 2. Plot the point and then connect these 2 points to make our graph. All right, looks like that's the last problem. But there's a word problem that I wanted us to try, number 10. Yes, let's look at number 10. So number 10 says, suppose the number of households, Y in millions, that give you at least one television set can be estimated by the linear equation y equals 1.3x plus 94, where x is the number of years after 1999. So in this particular problem, You first want to be able to understand what does the X and the Y represent in your ordered pair. So our X and Y coordinate are represented by information that's given to us in this question. It says Y is the number in millions of people who have at least one television. So we need to know that. Number of people with a television. And it's represented in millions. Number of people with a TV. And then the X coordinate, you're told, is the number of years after 1999. We could just simply count up after 1999 to determine what the X coordinate represents. A number after 1999. For part one, we have to find which of these graphs is correctly representative of the equation y equals 1.3x plus 94. Notice our equation is in slope-intercept form. So this is our slope, 1.3, our y-intercept, 94. Now our slope, remember, is rise over run, right? Which is a fraction. So what we're saying when we say that our slope is equal to 1.3, that means that when we divide the fraction, we should get 1.3 for slope. Our y-intercept, or where we cross the y-axis, let's look at each of these graphs, and we want to make sure that we find the graph that goes through the y-axis at 94. Now our graphs begin at 60 and it shifts up to 120. So between each of these spaces, there is 10. So 60, we have 70, 80, 90, 100, 110, 120. So each of these spaces represent 10. And we want to find the graph that goes through this y-axis at 94. So 70, 80, 90. That looks like it could be about 94. 70, 80, 90, about 94 here. 70, 80, 90. Okay. About 94 for letter B, and 70, 80, 90, about 94 here. So all of these graphs look like they're starting from a y-intercept of 94. But we notice some shifts. For letter A, our graph goes downward. Letter B, it goes up a little bit. Letter C, it goes up. And for letter D, it goes down. Look at our slope. Because our slope is positive, that means that our line has to increase. If you have a positive slope, then our line will have to increase. Therefore, we can eliminate the lines that are going downward. So letter D cannot be our graph because the line goes down. Letter A could not be our graph because the line goes down. So now we're only focusing on either letter B or letter C. Both of these graphs go through the y-axis at 94. We just need to look at the slope. So let's find the slope for letter B and letter C using our slope formula. Remember our slope formula, let's write it down here, is y2 minus y sub 1 divided by x sub 2 minus x sub 1. We would choose 2 points on the graph. Now we want to find points that we could easily identify, like here at 10 on the x-axis, we see a direct intersection between the corner at 70, 80, 90, 100. So that ordered pair would be 10, 100. So we'll use this ordered pair as our first point, 10, comma 100, and we're labeling as x sub 1, y sub 1. Now our second point, let's find another space where we directly cut through a point that we know. Now we know that our y-intercept is 94, so we could use 0 and -4 as a second point. So 0 and 94 as a second point. So this will become x sub 2 and y sub 2. Now, when we substitute these values into our formula for the slope, remember we have y sub 2 minus y sub 1. That would give us in our numerator y sub 2, 94, minus y sub 1, which is 100. In the denominator, our x sub 2 is 0, minus our x sub 1, which is 10, and we want to simplify this. So 94 minus 100 in our numerator. We want to make sure we use that subtraction. And 94 minus 100 would give us negative 6 in our numerator. 0 minus 10 would give us negative 10 in the denominator. Now, if we simplify this, and you just want to simply divide these two in your calculators, you'll get 0.6. Now, 0.6 we know is not equivalent to 1.3. Therefore, letter B cannot be our graph because the slope is not large enough. But let's confirm this by checking the slope or approximate slope, because we are making estimates here for our second graph. So by default, letter C has to be the right answer. But we'll have to find 2 points in order to calculate a slope. So our 10 doesn't cross in the corner, we wouldn't use that point. Perhaps here at 0.5, 1, 2, 3, 4, 5, and up to 70, 80, 90, 100. So 5, 100 would be a point that we could use. 5, 100. And we'll make this our x sub 1, y sub 1. And for our second point, we'll use the y-intercept again. So 0, 94 would be our x sub 2 and y sub 2. So to find our slope, we'll have y sub 2 minus y sub 1, or 94 minus 100 in the numerator. Our denominator, x sub 2 minus x sub 1, will be 0 minus 5. Now this time when we subtract, we'll get 94 minus 100, or negative 6 in the numerator. And in the denominator, 0 minus 5, or negative 5. That'll be positive 6/5. And when you divide this, you'll get a decimal close to 1.3, 1.2, and then it increases. So your decimal will be a little bit over 1.2. This would be our slope because it's very close to the 1.3. Therefore, the correct graph you would choose is letter C. So letter C is the graph you want to choose for part A. Now for part B, you're going to complete this ordered pair. Look at our ordered pair is 5, comma, and then a missing space. So we're completing this ordered pair 5, comma, missing space. So we're looking for the y coordinate is what we're looking for. We would use our given equation, and we're going to substitute 5 for x into the given equation. Remember, the equation was given to us as y equals 1.3x plus 94. That was given to us in the question, in the directions. So here for our x coordinate, we're going to substitute 5. 1.3 times 5 plus 94. So 1.3, when we multiply our 1.3 times 5, we'll get 6.5. And 6.5 plus 94 will be 100.5. That's our y coordinate, and that's what we'll fill in this space with, 100.5. Now, for part C, you're asked to choose the sentence that best describes the meaning of this ordered pair. Now, we talked about what the x and y coordinates mean at the beginning. X represents the number of years after 1999, so we're saying 5 years after 1999. So if I have 1999 and I add 5 years later, that'll be 99. 2000, 2001, 2002, 2003, 2004. So this represents the year 2004. If we look at our answer choices, they all have 2004, so we know that part is correct. Now the second part, 100.5, that's our y coordinate. And remember in the directions it says y represents the number in millions of people that have at least one television. So we're saying 100.5 million people have at least one television. So let's see which of these sentences correctly talk about in 2004 there being 100.5 million households with at least one television. So part A says in 2004 there were 105 million more households with at least one television set. It doesn't say 100 more. It just says at least one television. So letter A would not be correct. Letter B, in 2004, at least 105 million more households had only one television set in 1999. All right, not correct. In 2004, letter C, there were 100.5 million households with at least one television set. All right, that looks close to our wording. Let's look and see. Suppose the number of household Y in millions that have at least one television set. All right, so this letter C looks closest to what the directions tell us. Okay, they had at least one television set, so we choose letter C. And that's the end of the Module 8B notes.